All right. Hello, everyone. Happy game programming day. We're back to working on our space shooter. Let's go ahead and take a look at where we left off. So I have this really cool ship. I have enemies flying in. I can left click or hit the space bar and I can fire my little rockets. Let's go ahead and have our enemies fire back at us. So let's go back into our project here. Now, to be more modular and clean, we'll just use the exact same shoot script. And remember, this is just controlling firing for both our enemy and our player because they have this similar mechanic. And so what I'm going to do is I'm going to select my enemy ship 01 here. This is our, essentially, this is our ship, right? Our enemy ship. And this is, remember, under our prefabs folder, we have our waypoints here. Just kind of going, give us an inventory if you haven't worked on the project in a while. So inside of here, all I'm going to do is either grab my shoot script. And if you have difficulty dragging this, you can just do add component and you can type shoot. And you can add that shoot script here. And for the projectile, I'm just going to grab my red projectile here, and I'm going to drop that inside of here. All right, I'm going to go ahead and pause the video and open up my shoot script here, which you can do by double clicking here, or you could double click it here. All right, I was helping a student on their laptop, and I noticed that the video looked very small. So I'm going to try to go as big as possible when working on the script. So something like this, so that you guys can see it a little bit better on your screens. All right, now currently we're checking is firing to see whether we're firing or not, but we need another control to check whether who's firing. Is it the player or the enemy? So I'm just going to hit Control D and duplicate this is firing here. And I'll space these out. I'm going to make this a serialized field. And instead of saying is firing here, it's which one is actually using, are we currently using the artificial intelligence, which is the enemy, or are we using the player? So we're just going to do use AI. And this is, again, Booleans are true false values. So I'm going to go ahead and hit Control S to save this. All right, so inside of start here, I'm going to hit enter and I'm going to type if, and I'm just going to select this first option here. If you struggle with getting your curly braces to line up, I definitely suggest that you take your time when you're making these videos. You use IntelliSense to kind of help you write the code for you. So like notice I hit if, I selected the top one and it automatically created that for me. Now, if we are using AI, which means this is true, that we're currently using our enemy is currently doing it, we're going to set is firing to true. Let's save that. Now, the way that we could always have this on is if we go back to this enemy ship here, you'll see now we have this exposed use AI value, and we can check that on. On our player, we're going to leave this off here. So this is saying, okay, this particular ship is an enemy. And with this always being on, it'll always shoot. Now, if we hit play, you're going to notice that our enemy is shooting, but it's going to be shooting in the wrong direction because they're following the same direction as the player is. So see how they're shooting upwards here? And what's cool is because these scripts act independently, on our enemy ship, I can adjust the speed of those bullets and actually the number, the firing rate, which might be a lot for us to dodge with this many enemies. So let's go ahead and open up our enemy spawner script because this controls the rotation and all the instantiation in our script. So let's go to enemies here. We have our enemy spawner script. I'm just going to drag that inside of here. And if you remember, we instantiate our enemies here. And the first element inside of here is what is the actual prefab that we want to instantiate? And then what is this position that we want them to instantiate? And then what is our current rotation? That's what quaternary identity is. So what we can do is we can actually rotate our character downwards so that it could fire downwards. So identity is great because it allows us to use the current direction of our ship to it says whenever this is spawning, it's using the current direction of whatever this script is attached to. What we want to use is an Euler anchor, which is named after the mathematician. And what's nice about this is this gives us access to the X, Y, and Z axis. Let's see if I highlight over this if it shows us that. Yeah, so you see how it says Euler float, 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 or you could use a vector 3 here. And so this gives us more fine tuning of the rotation of the angle that we want them to be spawned at. So how do we know which one to rotate at and what degree? Well, we could just grab our player ship here. I'm going to hit F to focus. And if we look at our rotation settings here, if I rotate it on X, that's not what we want. If I rotate it on Y, that's not what we want. But if we rotate it on Z, you can see that's what we want. And we want those ships to rotate downwards. So what we can do is if I type in 180 here, you could see this ship is facing downward. Now, I don't want to do that with my player ship. I'm just using that as an example. So I could just type in 0, comma 0, comma 180. And now when they spawn, they'll face downward. So I'm going to save that. Let's go ahead and press play and test that. And really, the artwork itself could be rotated as well, but now you can see they're rotated downwards. And because they look pretty much the same top or bottom, you don't really notice anything. Now, the same thing as before, you can see I'm being hit and my ship dies, but there's just way too many. So what you can do is play with these numbers. So like instead of the firing rate being 0.5, we could do 2 or something. I'll try 1. And then projectile speed can be much slower. We can make that, I think 10 was pretty slow, but let's make it 5. Just giving, and then over time, they get harder, right? The ships get faster, there more lasers happen. So now when we're moving, you can see that gives us a little bit, we're able to kind of dodge them a little bit better. But there's a lot of ships, and I don't know how I'd get out of this one. There we go. So kind of like almost like a puzzle, right? So we could play with that as well. So that, again, playing with these numbers so that it's not so crazy. All right, so let's go back to our shoot script and tweak a little bit of the enemy's firing. So if we scroll down here, remember this coroutine here is really what's handling all of our firing, right? This is where we're instantiating our red projectile or blue. And then we have our rigid body here, which is adding force. And if our rigid body is attached, that's why it's saying not equal to null, we'll actually we'll transform that up, right? We'll move the projectile. In our case, we rotated our ship so it's shooting down, and we destroy it after a specific period of time. Now, what we can do here is if you see this yield return new wait for seconds firing rate, this is what we're using to control the firing rate. And there's too many. What would be nicer is if we actually created a random number. And we've actually done this before, which you've maybe forgot about. So if we look inside of here, if we look at some of our older scripts, we have this scriptable object. So let me go ahead and drag this in, this waypoint scriptable object. And I believe it's inside of here. Let's see. Actually, I don't think we got around to it. So let's go ahead and write this as well. What I'm going to do is let's work on making some random bullets, like randomizing the bullets that fire from the ship. So let's go back to our shooter script here. So let's go ahead and do a little bit of math to randomize this. So we have our firing rate here. Let's go ahead and rename this to, I'm going to hit F2 on this, base firing rate. And let's go ahead and hit next, allow that to rename it. And then I'm going to get rid of this, kind of the formalized serialized field here, just to close this out. I hit F12 by accident. That gives you context, so like it'll go to the actual script where it's kind of formed or created serialized field. So in order to create some sort of random number, you need at least a base number, and then you need like kind of a min and max. So I'm going to duplicate this twice. And so for this one, we're just going to name it the, we're going to name this firing rate variance. And this is going to be our variance between the different firing rates. And then we need a min number. So this will be min firing rate. So for now, this firing variance, we'll just make this 0. And then we'll make this one like 0.1 until we figure out what values work best. So let's save that. So let's go back down to our coroutine here. And we'll do this after destroy. And what I'm going to do is I'm going to make a temporary variable that exists only in this coroutine. And it's just called time to next projectile. And this will be the time that we have firing between each projectile. And you probably guessed what I'm doing here from the other projects is we're going to be using random.range. And this will automatically generate a random number between two values. So if we highlight over this, let's see if I click in here maybe. Well, the two values we can do base firing rate, and then we can do a second value. And what we'll do is I'm going to go ahead and hit comma here, and then I'm going to do base firing rate again. Now, the way that we get two different values is if we subtract, we have our base firing rate minus our firing rate variance. And then I'm going to go ahead and I think this might be different. And let's see. We'll do this in a second. So, and then I'll just copy all of this. And then our maximum value is going to be base firing rate plus firing value. And I believe in Unity 6, this might be different. Change all to local range. Interesting. Well, actually, you know what? I think I'm missing the using directive. Sometimes it's just as easy as that. So it's not using Unity mathematics.random. Let's save that. I think that should fix it. We just want to use Unity math. Oh, and we want to get rid of this. Oh, yeah, we have it up here using Unity mathematics. Let's see. I actually had to research this. Sorry, I'm still transitioning to Unity 6. There's two different randoms. One is used by the C# compiler, another one is by Unity. This one is a Unity, the Unity version of random range. So the way that we were going to use that is we're just going to put Unity engine in the beginning and do random.range. And now what this will do is this will look at this as the min value and it'll look at this as the max value. Using the quote unquote random range code written by Unity engineers. So I'm going to go ahead and save that. And actually, I'm going to put this on another line because, again, like I said, I know some of you have laptops that have smaller screens. So now this time to next projectile will store a random number from the base firing rate, which if we go up here, remember base firing rate is 5, and we're just subtracting that by 0, and then we're adding it to 0. And we're going to change this value. Because right now you're like, wait a second, 5 minus 0 is, like 5, and then 5 plus 0 is 5. So how is this really giving me a random number between 5 and 5? We're going to, you'll see in a moment how we adjust this firing rate variance. Okay, I went ahead and wrote it out. I also adjusted it here. So let's go line by line. Just let me explain this to you. All right, so on line 70 here, we're using Unity engine.random range to generate a random float value. Now the range is centered around this base firing rate here. That's why it's both. It's in both of these with a plus minus firing rate variance. So what this does is if base firing rate is like 0.5, for example, and firing rate variance is 0.1, which again, we'll generate that later. It'll generate a random number between 0.4 and 0.6. Now, the next line we're taking the same time to next projectile variable and we're updating in here and we're using a mathf.clamp. And what this does is this ensures that the random time value stays within these acceptable bounds. And the acceptable bounds are what is the variable that we're looking at, and then what is the minimum and maximum firing rate. So the maximum is float.max value, which is effectively the upper limit of that value. And this prevents the random variation from making the firing rate too fast. Now I kind of explained this before, but the wait for seconds is actually at the time value to control the firing rhythm. And that randomization adds variation to make the firing pattern feel more natural. So the clamping ensures the weapon doesn't fire unreasonably fast, even with random variation. So this is like our lasers and stuff. So let's go ahead and put in that 0.1. So we have this is firing here. We have this use AI. And then, so essentially what we can do is for our minimum firing rate, let's go ahead and make this 0.1. And this will give us that value between 0.4 and 0.2 to 0.4 because it's between 0.1 and our firing rate variance, right, which is 0.5. Now, you'll notice that we have all of these variables that are getting stacked up. And if you're working with other programmers, they're going to get a little bit annoyed by that. So let's go ahead and break this up. So I'm going to, let's see, let's delete this. And where we start looking at our base firing rate here. So let's keep this up here. The stuff that we're really adding for our, and we'll move this Boolean use AI up here. So let's go ahead and just create a header. And inside of this header, we'll call this AI. And now when I save this, you'll see that we have a header that'll break this up so that we know which specific variables we're using for our AI. Oops. Let's kind of expand that out one more time. You can see now we have a nice little space and this says AI. If you want, you can make another one up here. And then because this, because we have it saying projectile setup here, I guess that's okay. We can leave it as projectile setup because this is kind of generic across all of them. And let's see. Looks good. Now this is firing. We even though we need it as public to access it from our other scripts, we can actually hide this by just doing we have another kind of flag. It's called hide in inspector. And because we don't want to make it private because we want to access it from other scripts and we're not really doing Singleton on this particular one. So we're going to go ahead and hit Control S to save this, and now you'll see that it hid it inside the inspector. So just a little bit of cleanup on those variables. Right, so let's go ahead and test this out. You can see now it's much more random like the games. There's just a lot of bullets. So we want to definitely, again, when we look at our enemy ships here, here's our enemy spawner. When we go to our enemy ship here, we would definitely want to keep playing with these values. Like projectile lifetime is fine, projectile speed is okay, but maybe this base fire rate, which is 5 here, maybe we make that 2. And then we just kind of increase or decrease that firing rate. You know, and then now I can just kind of like fire back, and maybe even my bullet speed needs to be adjusted. So this feels a little bit more like the shooter games because I can kind of like squeeze through, and it's not so, yeah. Maybe even I'll let you guys as the game designers adjust how long it takes. You know, how long they should be there, because otherwise it's just kind of, and maybe the projectile speed needs to be a little bit faster for these enemy ships. And then the base firing rate may be, again, longer. Anyway, I think that's good for now. This video is hitting like 20 minutes, and I hope that made sense. And I hope you enjoyed it.